Hi, this is Addition Properties, Lesson 2-7. Our goal for today, I can use the associative and commutative properties to add whole numbers and decimals mentally. Our state standard, we're just going to focus on the addition part of the properties. We do have these same properties in multiplication as well. So our addition properties. Commutative property. The order in which all added does not change the sum. So for example, if you have 7 plus 11, if you flip that and do 11 plus 7, they both equal 18. So you may see it look like this. 7 plus 11 is equal to 11 plus 7. That just means that the sum is 18, that the sum is equal no matter what arrangement you have. Same with decimals. 2 3/10 plus 9/5 has the same sum as 9 plus 5. As 9 5/10 plus 2 3/10. You may see it look like this. 2 3/10 plus 9 5/10 equals 9 5/10 plus 2 3/10. The sum is the same, no matter how you arrange the numbers. The associative property is just a way of grouping numbers. So if you're adding 3 digits, it's a way of grouping them so that it makes it easier to add them. The way in which numbers are grouped does not change the sum. So for example, if we have 9 and 9 plus 6 grouped plus 4, that has the same sum as if we had 9 plus 6 plus 4 grouped. And you may see that look like this. Parentheses, 9 plus 6, end of parentheses, plus 4 equals 9 plus 6 plus 4 in parentheses. Same thing with decimals. 1 8/10 plus 2/10 plus 5/10 that are grouped has the same sum as the grouping of 1 8/10 plus 2/10 plus 5. And again, you may see the equal sign in between them. That just says that those sums are going to be the same no matter how they're grouped. And the last one is identity property. This one's pretty easy. The sum of any number and 0 equals that number. So for example, 14 plus 0 is 14. Same thing with decimals. 0 plus 6 75/100 is going to just be that number, 6 75/100. So let's practice. Identify the addition property used to rewrite the problem below. So take a look at that grouping and tell me what property they used. If you said the associative property, you're right. I like to think of the associative property as the numbers are associating with each other in groups. That's just kind of a little way I use to remember it. The grouping of all the numbers to be added changes. This is the associative property. So a little more practice. Why do we use addition properties? Well, here's an example of how to use these mentally. We have 3 numbers that need to be added. 8/10 plus 5 6/10 plus 4/10. So you may be saying to yourself, well, I need to start lining them up and adding them, but what if you had to add them mentally? Well, since 6/10 when we're looking at 5 6/10, let's just look at the decimal part there. The 6/10 and 4/10, if I added that mentally in my head, I know that that would be one whole. So I'm going to group 5/6 and 4/10 together. So once I've done that, I know that I've used the associative property to do that. So 8/10 plus 6 I'm going to add 5/6 and 4/10 mentally, and I will get 6 and 8/10. Can you explain when using addition property would be useful in a real-life situation? Give an example. Write your explanation down and bring it to class for our morning discussion. It's important to know how you would use this in a real-life situation, because otherwise, what's the purpose of learning it, right? We want to be able to use it in real life somehow. So your grading scale for today. I'm a 3. I know exactly how to use the associative and commutative properties. I understand how I would use them in a real life situation. I have no questions at all. I'm a 2. I'm kind of getting to know how to use the associative and commutative properties. I still may need a little practice with it, and I may have a few questions. Or I'm a 1. I really don't understand the associative and commutative properties. I don't understand how we would use them in a real life situation. I'm really confused. I have a ton of questions. Bring all that back to class on Monday and have a great weekend.